So today I will be solving a problem from code forces whose name is neutral tonality, and you can access this question in this URL, and it is a 1700 rated code forces problem. So I won't just read out the problem. I will explain the problem statements in my own words. Then you can pause the video and try yourself by your own. And if you fail, then you can view the solution that I will tell you. So in my words, the problems are in this problem. You are given two arrays, that is array A and array B. Array A is of length n and array B is of length m. Okay, you have two arrays. And if I talk about the range, this n can be up to 2e5 and n is also up to 2e5, and this elements, that is ai's or bi's, this both ai's or bi's can be up to from 1 to 29. Okay, so this is the overall range of this problem. So if I explain the problem, you have this array A, like A1, A2, A3, dot 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 An. I have this array A and I also have this array B. So the problem statement is that you cannot, so from these two array we have to make an array C of length m plus n. Basically we need to march these two array in a particular fashion by optimizing a certain parameter. So the thing is that you cannot change the order of this array A. You cannot change that. You can change the order of the array B and you can insert them in this array, right? And you can change the order in any way and you can insert anything anywhere. Like B3 you can insert here, like VM you can insert here, like BK we have BK you can insert here. So basically you cannot change the array A, but array B you can change, you can insert any value of B to anywhere of the array A, such that the LIS or the longest increasing subsequence of A is minimum possible. You have to insert these elements of B into array A such that the LIS. So if you insert all this value of B into array A, you will get a array C, right? So this C will be C1, C2, dot 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 C m plus n you will have. So you need to minimize the LIS of this array. And LIS is the longest increasing subsequence. And I hope you all know what is longest increasing subsequence. It is the thing that you can select some subsequence, or subsequence means you can take the elements of a particular array, but the order has to be maintained. You cannot interchange, like you cannot write C3 first then C2. So if you take in this way, then it is not a subsequence. So subsequence that you can take elements from this array, not necessarily continuous. You can take with certain gaps also, but the order has to be maintained, and all those value needs to be strictly increasing. So longest increasing subsequence, so increasing means strictly increasing. So that's the problem statement. So I hope that the problem statement is clear, and if you understood this problem properly, you can pause the video and run. After that, you can come and see the solution. So let me write the constant. So it is around 2e5 and m is also 2e5. So the expected time complexity could be linear, like order n plus m type, or order n plus m log n type. Something like m into n is not possible, so this kind of quadratic time in complexity is not possible because it will exceed 10 to the power 10 and which will not be acceptable. So you have to think in this way, either linear or some this kind of logarithmic type. So based on this constraint, our first job will be to find the expected time complexity by which we can solve this problem. So from this we get a hint that in which direction we have to go. So it is the first step. So I will write one test case and explain. Let me write the test case. One seven two four five. 1 7 2 4 5. I have an array A and I have an array B equal to 5 4 1 2 7. So 5 4 1 2 7. So and the answer C, and in this problem we need to output the array C. Okay, so outputting array C is what is expected. So we need to print n plus m elements, that is the elements of array C, and based on this problem the answer is 177. So this is the final array C, which is of length n. I think 1 2 3 4 5 6 7 8 9. Yeah, there is 1 5. So 1 7 2 4 5 is the element. So 1 7 2 4 5. So this is the elements of array A, and we have inserted this array B elements to here. And you can see that in this array A, if I calculate the LIS, so the LIS of A will be I guess 1 2 4 5. Yeah, that will be like LIS will be of length 4, which is 1 2 4 5. And if I see in this array, so same like 1 2 4 5 is the LIS. So and this is the minimum possible. So you cannot insert B so that you get an LIS less than 4. Okay, so you will not get, you can try, so you will not get. So this is the test case. So since I want the minimum LIS array, so we can insert B in any order. So the intuitive observation that I have is that we have to sort this in the descending order. Okay, so it is very intuitive because we don't want increasing sequence, but we can have decreasing. So the first is that obviously we will insert 7 first, then 5, then 4. In this way, in this order, we will insert. We will in this array, we will never insert like 4 and then 7 in some this way, because this 4 and 7 can increase the LIS. Okay, because this 4 can attach with some previous elements with A and then 7, then it will increase. So obviously we won't insert. Obviously we will insert this in the descending order so that we don't increase the LIS. And one trivial observation that is possible is that this LIS of C will always be greater than or equal to LIS of A, right? So if this is my longest increasing sequence, that is 1 2 4 5, so no matter how we insert this, we cannot get less than 4, right? No matter how we insert the elements from B to array N, no matter in which strategy we do, this 1 2 4 5 will remain as it is. Its order won't change. So this is a trivial observation, and we have thought that we will sort this in the descending order. So 7 5 4 2 1, right? 7 7 5 4 2 1, 7 5 4 2 1. After sorting in descending order, you will get this array, right? So just for easy solution, what to do? Just take this and put it just after A. Just append this entire sorted array B after array A, right? So you will get something like this: 1 7 2 4 5, then 7 4 7 5 4 2 1. So you will get like that kind of array, right? So let's say you have already sorted B. So I have certain A's, like A1 to AN, and let's say A5 I have, okay, and let's say in B I have 3 elements, so B3, B2, B1, and all these are sorted in decreasing order, just mind that. Let's say I just concatenate, okay, so in this case my N is equal to 5 and my N is equal to 3, right? So let's say I doing this and I try to find out what is the LIS of this array C. If I try to find out this, so you can see that at max this LIS of C can be at max less than equal to 1 plus LIS of A. So how is that? Because you see these are sorted in descending order, right? Let's say you got some LIS here. So like this you got some LIS. Let's say all this form an LIS, and it is possible that this B3 can be greater than A5, right? So after A5 you can take B3 in the sequence, but after you take B3 you cannot take any one of them, right? So among these three you can take only one at max. If this B3 is smaller than A5, then also you cannot even take this B's also, right? So at max, so this LI of C is always will be less than or equal to 1 plus LIS of A. So this is the upper bound that we got from this observation. So here is the question: is can I do it this LIS of A, so C is exactly equal to LIS of A. So this is what we need to find it out. If this is possible or not. If this is possible, then that is our desired answer. So let's try. So since it is a constructive problem, we need to construct. So let's try to put these values of C into the array A and try to see what happens. So you can just think, is there any way by which we can do this that can satisfy this? Okay, and also we need to check that is it always possible or not. Like LIS of C will always be equal to LIS of A. One is for sure that LIS of C will be greater than or equal to LIS of A. So this LIS of C can either be LIS of A or LIS is plus 1. So this is what we need to optimize, right? Yeah. So say I have some values like A1, A2, A3, some and I have some values here and some values also here. And let's say this A1, A2, A3, A4, A5 form the LIS, right? Let's say I imagine this. And the elements are present here also, where the other elements are present, but only these 5 elements participate in the LIS. So since LIS is a popular problem in DP, so you can think of let's find out the LIS, okay, the LIS sequence. But if you find this by dynamic programming, you will have to use this order of n square. But seeing at this constraint, you cannot apply dynamic programming. So in simple words, you cannot find the longest increasing subsequence in this array A. You cannot find. Without this only, you have to solve this problem. So that's a challenge, obviously. So I have the B's, B, that's a B3, B2, B1 I have. Let's imagine one thing. Let's say I am taking a very simple example, like 1, 2, 3. It is the array A, and let's say I have 4, 3, 2. This is the array B. Okay, this is the array B. So if I insert it at the back, so initially it was 1, 2, 3. After inserting this, the length increased by 1, so that is 4. So I can see that this is the element which is causing problem. So if I just remove this and put this 4 here, then you can see that it is still 3, right? And also you can put this back also here. It actually doesn't matter. It's still 1, 2, 3 is the longest increasing sequence, right? So from this example, we can see that it's possible that LIS of A is equal to LIS of C. For this example, it's possible. So we need to just make sure that is it possible for each and every possible values of array A, or this is the special case where it has been followed. So we need to handle these two conditions, right? So let's say I have some, let's say Bj I have. So just imagine this Bj is greater than A3. Okay, this Bj is greater than A3. If this is the case, I insert this here. So I get Bj, and obviously it is greater, right? So in the previous A, I had the longest increasing sequence as this, right? So since this value is greater than A3, since this Bj is greater than A3, so obviously in the longest increasing subsequence, Bj won't be counted. But if Bj was less than A3, right, like something less than A3 and also greater than A2, so if I have something like Bj, then this Bj will be counted in the longest increasing subsequence. So one thing for sure, that whatever value we try to insert here, this Bj will definitely be greater than or equal to A3 or this. Okay, so this is from a trivial observation that I got. Okay, and obviously this Bj has to be greater than or equal to A3. It cannot be less than, because if it is less than, then this might come in the increasing subsequence. Okay, so the thought process that I got is that I will insert the Bj before some AI. I will insert Bj before some AI if Bj is greater than or equal to AI. Okay, so this is my idea, or this will be my strategy of inserting the Bj's, right? So I will insert Bj if Bj is greater than AI, right? So in this way I will try to insert. So now I need to make sure that if I insert in this way, then this LIS of A is equal to LIS of C. I need to make sure and I need to prove this. Okay? So let's prove this, that will this work or not. So I said I need to prove because I have solved this before, but when you approach this kind of problem for the first time, you must think that is it possible that LIS of A is equal to LIS of C? Is it possible? So you should try to prove that is it possible or not. Since I solved, so I know that it is provable. But if you encounter this kind of problem for the first time, so you should think of multiple scenarios and you should try to prove all of those. And if you get the answer, then only you can move forward with the coding and you can solve the problem, right? So I have this let's say A1, A2, A3, A4, A5, A6, minus 1, A8 I have, right? So I hope that the board is visible till here. So what I say is that if Bj let's say bj, and just note that bj will be traversing in the decreasing order. So we have already sorted it. Okay. So and in m log n we can sort, right? So the thing is that let's say we sort this bj and we try to insert bj here, and let imagine that we insert bj here, and obviously from my previous argument bj will be greater than a3, right? Bj will be greater than a3. So let's say I don't know that where is the LIS. I insert here. The LIS could be here, the longest LIS obviously. The LIS could be here, or it could be overlapping also. I don't know that what is the position of LIS, and I cannot find it with this constant, right? So I have to check three cases. In first case, that LIS is on this side. Second case, LIS is on this side. Third case, LIS is on the overlapping. Okay. So I need to check. So let's first analyze this case, right? So let's say I have the longest increasing subsequence somewhere here that starts here and ends here, right? So if this is the case, is it possible that bj will be an element of this increasing subsequence? Means I want to say that if along with this subsequence, if I add bj, will it increase the length by 1? The answer is no, because you can already see that bj is greater than a3, right? So if bj is a potential element, if bj will be added to this, then obviously why I will take bj? I will take a3, right? Because a3 is smaller than bj. So if bj becomes a part of this subsequence, then instead of bj I can take a3, right? So if you insert in this way and if the subsequence lies in this way, so we will never choose bj if bj is greater than a3, because I will take a3 obviously. So if my subsequence lies in this area, then I won't be taking bj. So okay, so this is solved. Now the second thing is that let's say if so the subsequence lies in between, like for this case, right? So in this case also, after a1 I am doing a3, a4, a5, a6, so it is the LIS. So since bj is greater than a3, so if I insert something bigger than a3, so it won't be counted in the subsequence. So if it is overlapping, then so if it is overlapping, then the problem is solved, because still the LIS of A is equal to LIS of C. Now the third case that is a bit tricky that I found is that let's say I have this AIs, I insert BJs, and obviously BJ is greater than AI, and my LIS is here, right? So you can think like if the last element of the LIS, let's say AK, if AK was less than BJ, then this after AK we can take BJ, and so it will increase the subsequence by 1, right? So if I give one example, let's say this increasing subsequence ends with 18, right? And I have here 15. So and I have inserted B at 16. So initially after 15, since I don't have 16, sorry, I did a mistake. So I will write here 19, right? Yeah. So after 18, I have 15. So the longest sequence ends here. Since 19 is bigger than 15, so I have inserted here, right? But after 18, this 19 will be counted in the longest subsequence, so the LIS length will be increased by 1. But we will avoid this case because we will insert these values of A sequentially, right? So since this 19 is bigger than 18, so before coming to 15, we will come to 18, right? So this 19 will be actually be inserted here. So all the values that I will have, that will be less than 18 actually, because all the values greater than 18 I had already inserted before because I am traversing this sequentially. Okay, so this will be the main logic of solving this problem. So in this way, I have proved that this LIS of A will always be equal to LIS of C. So this is what I have proved. So I hope that you understood the problem, and I think you can write the code by your own, and there is nothing difficult to write this code. But still, if anyone faces any issue with the code, so I will just give a small pseudocode. So this AN and BN array you take as input, right? And obviously sort this for this array B in descending order, right? So you apply the comparator. Okay, you can do it in Java. If you do, the syntax will be different if you change the programming language. So in C++, you can write something like this: sort b dot begin comma b dot end greater int a bracket open close. So in this way, you can sort the array B. So you just sort this array B. Since I am writing the pseudocode, so I won't do this in decreasing order. So now, so I will hold a pointer in the first element of B, right? Then for I equal to 0, I less than n, I plus plus. Before choosing an element of B, what I will do, I will check that if B of J is greater than A of I, right? So if this Bj is greater than A of I, then we can insert, right? So if this is the case, then we can. So since we are printing it, so I can just see out here B J. In this way, I can do also J plus plus. And after that, I will see out the AIs. Okay, so this and one more thing. So let's say in the A I have, let's say 5. It starts with 5 and let's say 10, something like that is there. And in the array B, let's say in the decreasing order, I have 15, 14, 12, then 9, something. I have the array B and I want to insert it. And so currently my I is in this position and the J is in this position. So I check that J is greater than AI. So I print this Bj and I move this pointer. Okay, but then see, after that also this Bj is still greater than AI. So, okay, so we won't move the pointer. So rather, instead of if, we will do here while, because until and unless this is true, we have to loop. Okay, and one more boundary condition that I will have to check that this J must be less than n. Okay, and note that you have to write this in front. Okay, then this one. Otherwise, you will get that index out of bound error. Okay, since you have to check this first, so you have to write this first, then then this one, right? So it is a separate check that you have to do. Okay. So yeah, so this is a very yeah, and after that also, but after this you have to print the values of B if anything has left. Okay, so let's say the last element of B was, the last element of A was 10, right? And in the array you still have these two elements, right? So this I has come here, that is this loop has ended. Okay, but since you didn't get a value smaller than 2, like you didn't have anything like this, so you haven't inserted this before 1. Okay, so whatever element was left at B, you have to insert those at the end of A. Okay. So for this, after this, you can just print the rest of the element. That is why J is less than N. C out B of J plus plus. Right. In this way you have to do B of J plus plus. Right. So after this, you have to print all the rest of the elements of the array B. Okay. So in this way you can solve this problem. And if I talk about the complexity, so we first did the sorting, so it is m log m. After that we have just printed it, right? So it is plus m plus n, because just we are just simply checking and we are just printing, and in both cases either this I is moving or j is moving, and so once both pointer reaches the end, each and every value gets printed, so it is over, right? So this will be the typical complexity. Okay. Yeah, so this is all about the problem. I hope you understood it. So I found this problem bit interesting, so I made the solution. I hope you understood something and you learned something. So yeah, thank you for watching.